So, imagine for a second that you could just walk up to this giant industrial dial, grab the heavy handle, and simply turn down the temperature of the entire planet.
Oh, wow.
Yeah, not through the, slow, grueling work of overhauling our global energy grid or spending decades begging nations to cut emissions. I mean, literally turning a physical dial and just deliberately tinkering with the Earth's climate systems on a massive scale, just to cool things off today.
I mean, it is a striking image. It sounds like something straight out of a science fiction novel, honestly.
Right.
Or maybe one of those superhero movies where the villain has a weather control machine hidden in a volcano.
It totally does.
Yeah.
But this isn't science fiction, and it's not a movie plot. So welcome to today's deep dive. We are looking at a concept that used to be considered completely taboo by the scientific community.
Really untouchable, yeah.
But now it's being discussed at the highest levels of research. It's a field called geoengineering. And for those of you who might be encountering this term for the first time today, let's just establish a clear definition right at the top.
Good idea.
Geoengineering is basically the intentional, large-scale manipulation of the planet's climate to counteract global warming.
And that word, intentional, does a lot of heavy lifting there, I think.
Right.
Humanity has, of course, been unintentionally altering the climate for a very long time through industrialization. But geoengineering is about doing it on purpose. And the shift in how scientists are treating this is, well, it's profound.
Because they used to hate this idea, right?
Oh, absolutely. Until very recently, most mainstream scientists wouldn't even touch it. It was considered fringe, dangerous, and, highly irresponsible to even discuss in polite academic company.
Yeah, because even talking about it felt like giving up on fixing the actual root problem.
Precisely. That was the fear. But as the climate just keeps warming and the impacts get more severe, a growing number of researchers have begun to study these interventions seriously.
Out of necessity.
Right. But the crucial distinction to make here is that they aren't studying it with enthusiasm. They are approaching it with a profound sense of wary responsibility.
Yeah, that makes sense.
There's actually a very powerful metaphor in the research that I think sets the perfect, kind of unhurried tone for our discussion today. Scientists are studying geoengineering the way you might study a fire escape that you hope you never, ever have to actually use.
Wow, that is such a vivid and honestly somewhat chilling way to frame it.
It really is.
Like, you want to know the fire escape is structurally sound, you want to know where the steps lead, but you are praying the building never catches fire to the point where you have to, break the glass and climb out.
Exactly. You want it there, but you don't want to use it.
Right. And to understand this planetary fire escape, we first have to realize that geoengineering isn't just one big button on a control panel. It's actually two completely different approaches.
Yes.
And confusing these two approaches seems to be the cause of a lot of muddled, panicky discussions out there.
Definitely. When people hear the word geoengineering, they tend to just lump every single proposed intervention into one chaotic bucket.
Yeah.
But the absolute first key to thinking clearly about this topic is to split it into two distinct families.
Okay, so let's split them.
Well, what's fascinating here is how fundamentally different they are in their underlying mechanics. So the first family focuses entirely on reflecting sunlight.
Okay.
The whole goal is to reduce the amount of the sun's solar radiation that actually reaches and warms the Earth's surface.
Got it. And the second family takes a completely different route.
A little different. The second family is all about removing carbon dioxide. So this means treating the atmosphere like a sponge we need to wring out, literally sucking the main greenhouse gas back out of the air after it's already been emitted by power plants and cars.
So they share the exact same ultimate goal for you and me, which is cooling the planet down. But because they work in completely opposite ways, they have completely opposite profiles of risk and reward.
Yes, that's a great way to put it.
And since we are essentially talking about, playing God with the climate, I want to start with the option that actually terrifies me the most, this whole idea of reflecting sunlight.
Oh, it's definitely the approach that generates the most sensational headlines. And the inspiration for this actually comes directly from observing nature.
Right, the volcanoes.
Exactly. When a large volcano erupts, it doesn't just spew lava. It can fling a massive haze of tiny sulfur-rich particles way, way high up into the stratosphere.
The stratosphere being the upper layer of the atmosphere, right? Like way above where our daily weather happens.
Yes, far above the clouds. And once those tiny particles are up there, they spread out and act like billions of microscopic mirrors. They increase what scientists call the Earth's albedo, which is simply a measure of reflectivity.
Okay, albedo.
Think about wearing a black t-shirt. versus a white t-shirt on a sunny day.
Oh, right. The white one is cooler.
Right, because the white t-shirt has a higher albedo. It bounces the solar energy away. So these volcanic particles bounce a fraction of incoming sunlight back out into deep space before it can even touch the lower atmosphere.
And we've actually seen this happen, right?
We have. We have observed this phenomenon measurably cooling the entire planet for a year or two after major historical eruptions. Nature has literally proven the mechanism works.
So the human proposal here is to essentially build an artificial volcano, or at least mimic that natural cooling effect.
Basically.
The idea is that we would deliberately and continuously spray reflective particles using like specialized fleets of aircraft flying at super high altitudes to create this permanent haze.
Exactly.
And the goal would be to dim the sun just slightly, just enough to take the edge off the warming.
That is the core of the concept, yeah.
Okay, let's unpack this because I'm looking at the economics in our sources and it suggests this would be relatively cheap to do in the grand scheme of global budgets.
Surprisingly cheap, yes.
And it would work incredibly fast. Like we could theoretically start cooling the planet within a matter of months.
We could.
Wait, hold on. If this sunglasses method is as cheap and fast as you say, and we have people literally dying from extreme heat waves all over the world right now, isn't it actually unethical for scientists to keep this locked away in a drawer? Why aren't we just doing this tomorrow to save lives?
It's a fair question. But it's because the risks associated with dimming the sun are just profound and far-reaching. First and foremost, you have to look at the chemistry of the atmosphere.
Okay.
Reflecting sunlight doesn't fix the underlying problem of carbon dioxide accumulation. The CO2 is still up there, acting as a thick blanket, and human civilization would presumably still be pumping more of it into the sky.
Because we wouldn't feel the heat as much, so we'd keep burning fuel.
Exactly. And carbon dioxide doesn't just sit in the air trapping heat.
Yeah.
A massive, massive portion of it gets absorbed by the world's oceans.
I want to pause on that for a second because the mechanics of ocean absorption often get glossed over in the news. How exactly does that work?
So when carbon dioxide meets seawater, they react chemically to form carbonic acid.
Oh, it's like pumping carbonation gas into a soda machine, making the water acidic?
A very apt comparison, actually. And as the oceans absorb our excess carbon, the water becomes increasingly acidic. This literally dissolves the calcium carbonate shells of marine life.
Oh, wow.
We're talking everything from tiny plankton at the base of the food chain to massive coral reefs. So dimming the sun by spraying particles into the stratosphere does absolutely nothing to stop ocean acidification.
Nothing at all.
Right. You are entirely masking the warming symptom while allowing the underlying disease to just ravage the marine ecosystem.
So we get cooler air, but dead, acidic oceans. I mean, that alone is a massive catch.
It gets even more complicated than that. Tinkering with incoming sunlight alters the fundamental energy balance that drives global weather.
How so?
Well, the uneven heating of the Earth is what creates wind, rain, and ocean currents. By artificially altering how much solar energy hits different parts of the globe, you risk wildly disrupting rainfall patterns.
Yeah, the research indicates this could be incredibly uneven. Like, putting these particles up there might successfully cool down North America, but in the process, it could cause a catastrophic failure of the monsoon season in South Asia.
Exactly. And this raises an important question, perhaps the most unsettling geopolitical dilemma in the entire field. Who gets to control the global thermostat?
Right. If spraying particles saves one country's agricultural sector from drought, but triggers mass starvation in a neighboring country because their rain just stops falling, how on earth do we navigate that?
It's incredibly messy.
There is no global United Nations consensus mechanism for manually setting the Earth's daily temperature.
There isn't.
Yeah.
And the potential for conflict is staggering.
Yeah.
But that geopolitical nightmare leads directly into a physical risk that the research highlights.
Okay, what's that?
What happens if we start doing this, we become dependent on it to survive, and then the system breaks down.
Oh, man.
Say there is a massive global economic depression or a world war, and the international community simply runs out of money or cooperation to keep flying these high-altitude spraying missions.
I read this part of the source material, and it gave me actual goosebumps. There is a specific technical term for this scenario, termination shock.
Termination shock, yes.
Okay.
It is every bit as ominous as the name implies.
Wait, I need to make sure I understand the physics here. If we are just blocking sunlight, and then we stop blocking it, wouldn't the temperature just go back to whatever normal was? How does the heat come back so aggressively?
Well, because while you are blocking the sunlight, human society continued emitting greenhouse gases. The invisible blanket of carbon dioxide in the atmosphere got thicker and thicker and thicker.
Oh, I see.
You were just preventing the sun's energy from getting trapped by it during that time.
Here's where it gets really interesting or terrifying for you listening. Think of it like this everyday analogy. Imagine you are pressing down on a giant, high-tension metal spring with your thumb.
Okay.
You are actively suppressing all that potential kinetic energy. You are holding it back with sheer force. But the spring is getting tighter and tighter underneath.
Right.
If your thumb slips or your arm gets too tired and you finally let go, all that force doesn't just gradually return to a resting state. It violently releases all at once.
That perfectly illustrates the mechanics. If we suddenly stopped maintaining that artificial layer of particles in the stratosphere, all the suppressed warming driven by that massive hidden buildup of carbon dioxide would come roaring back.
We are talking about a sudden vertical spike in global temperatures.
Yes, the speed of the temperature change is the true danger here. The planet would warm far faster than any natural ecosystem could migrate or adapt.
Because it happens so fast.
Exactly.
Hmm.
Human society wouldn't have decades to slowly relocate coastal cities or, slowly shift agricultural zones northward. You would have a matter of years. The shock to the system would be devastating.
So, by turning on this dimmer switch in the sky, we would be committing all future generations to keep it running indefinitely without fail.
Yes, forever.
We would be handing our great-grandchildren this massive, terrifying planetary life support machine and saying, whatever you do, don't ever let funding for this drop, or you'll all burn up.
It's a huge burden.
It makes perfect sense why the scientific consensus studies this purely so we understand the threat, not because anyone is eager to launch the planes. It is a permanent generational trap.
A trap that forces us to pivot to the second family of geoengineering. Because if reflecting sunlight is the fast, seemingly cheap, and terrifying trap that only masks the symptoms, the second family is the one that actually tries to treat the root cause of the fever.
Right. Removing carbon dioxide from the air.
Exactly. The appeal here is purely logical. If putting greenhouse gases into the atmosphere caused the problem, taking them back out solves the problem.
Simple as that.
In theory, yes. And there are two main avenues for doing this. The first involves gentler, nature-based solutions. This means massively scaling up the restoration of forests, vastly improving agricultural soils, and protecting coastal wetlands.
Using nature's own tools.
Right. These natural systems evolved over millions of years to pull carbon out of the air as plants grow, locking it away safely in roots, trunks, and deep soil.
And I think everyone listening can get behind that, right? Plant more trees, restore the swamps, bring back the deep root prairie grasses. It has the bonus benefit of restoring habitats for wildlife.
Win-win.
But nature takes time, and the source spends a lot of time on the high-tech versions of carbon removal. We are talking about giant industrial facilities built to chemically scrub carbon dioxide directly out of the ambient air.
Direct air capture, or DAC. And the technology is not science fiction. It exists today and is currently operating in several countries.
Okay, let's break down the mechanics of how you actually vacuum the sky. How do these machines work?
Well, picture massive banks of industrial fans, similar to the cooling towers you see on large buildings. These fans draw huge volumes of ordinary air and push it over specialized filters.
Okay.
These filters contain chemicals that act like highly specific magnets. They bind only to carbon dioxide molecules while letting the oxygen and nitrogen pass right through.
Oh, that's clever.
Once the filter is completely saturated with CO2, you have to heat it up to a very high temperature to release the pure carbon gas, which you then capture, compress, and ideally pump deep underground into geological rock formations where it eventually turns to stone.
I mean, that sounds like an incredible engineering triumph.
It is. But if we connect this to the bigger picture, we hit a really sobering reality check.
There's always a catch.
Always. The hurdle isn't the chemistry. The hurdle is the sheer scale and the energy cost. The amount of carbon humanity has burned and poured into the atmosphere since the start of the Industrial Revolution is almost incomprehensibly large.
Yeah.
Carbon dioxide is currently measured in parts per million. It is a trace gas, meaning it is incredibly diffuse in the air.
To put that scale into perspective for you listening, if reflecting sunlight is like putting a cheap pair of sunglasses on the Earth, trying to remove the carbon with today's direct air capture machines is like trying to vacuum an entire miles-long sandy beach using a tiny battery-powered hand vac.
That's a great analogy. The hand vac works. It does pick up sand. But the beach is effectively endless. pulling a meaningful fraction of our historical emissions back out of the sky using these machines is enormously expensive.
And we need so many of them.
Right, building the infrastructure requires staggering amounts of steel and concrete, and the machines themselves require a massive amount of energy to run, specifically the energy needed to constantly heat up those chemical filters to release the trapped CO2.
And if the electricity powering these giant sky vacuums comes from a power plant burning natural gas or coal, you are literally generating carbon emissions to power the machine that sucks up carbon emissions. You are just running in place.
Exactly. So the verdict from the scientific community on carbon removal is very grounded. The technology is real. It is absolutely worth developing, optimizing, and funding because we will likely need every tool available to clean up residual emissions in the future.
Right, it's part of the puzzle.
Yes. But it is painfully slow, it is currently exorbitant in cost, and is in no way a quick fix for the crisis we face today.
Right. Let's take a look at the landscape we've mapped out here. The first option, dimming the sun, is a terrifying generational trap that destroys the oceans and threatens global weather.
Yes.
The second option, sucking the carbon out with giant fans, is a slow, ridiculously expensive uphill battle. Given all those massive glaring flaws, why are scientists so incredibly worried about society simply talking about geoengineering in public?
Yeah?
Because the source spends a significant amount of ink on this specific fear. It brings us to the heart of the debate, which turns out to be less about atmospheric physics and entirely about human psychology.
Yes, this is perhaps the most crucial insight of the entire discussion. It introduces a central behavioral concept called moral hazard.
Moral hazard. Let's define the mechanics of that for everyone.
So in economics and behavioral psychology, a moral hazard occurs when an individual or an institution is protected from the negative consequences of their actions. Because they feel protected, they end up taking much bigger, more reckless risks. In the context of the climate, it becomes a very dangerous psychological trap. The deep-seated worry among scientists is that if the general public, and far more importantly, politicians, policymakers, and fossil fuel executives, come to believe there is a magical technological escape hatch waiting in the wings to cool the planet later, they will feel much less urgency to do the genuinely hard work today.
It's a classic human rationalization. It's like eating a dozen donuts every single day because you convince yourself, well, I'll just get liposuction next year, so my diet today doesn't really matter.
Right.
You use the promise of a future technological fix to avoid changing your current behavior.
It becomes a very comforting narrative. It gives society a convenient excuse to delay the massively disruptive, expensive work of transitioning our entire global economy away from fossil fuels.
Which is what we actually need to do.
Exactly. It provides cover for industries to say, let's keep drilling for oil. The scientists will just dim the sun or vacuum the sky when things get too hot. The researchers who study these climate interventions are emphatic on this point. They see their own work being weaponized as an excuse for inaction.
So what does this all mean? The scientists' most urgent, non-negotiable point is this. Geoengineering is absolutely not an alternative to reducing emissions.
Never.
Treating it as an alternative is a catastrophic mistake. Cutting greenhouse gas emissions at the source, stopping the pollution from entering the sky in the first place, remains the absolute bedrock foundation of human survival.
Absolutely.
Geoengineering is a tool you might consider holding in your left hand alongside emissions cuts in your right hand, but you never, ever use it instead of them.
It functions as a supplementary emergency tool, never a replacement for a cure.
Right, so how should we integrate all this deeply complex information?
Well, the scientific literature offers a very clear prescription for how to view this field, and that is with genuine humility. The Earth's climate is a fantastically complex, chaotic system.
It really is.
Everything is connected to everything else. Deliberately intervening in it at a planetary scale means taking actions where we cannot possibly predict all the cascading consequences. Yeah. And as the text wisely points out, we cannot easily run a test run on a spare planet.
Right. We don't have Earth bees sitting out in the garage where we can try the cheap sunglasses on first to see if the oceans die.
We only have the one system. And that is exactly why the mainstream scientific response is to research carefully, quietly, and cautiously. We need to understand the physics of these options, their geopolitical risks, and their severe limitations before any world leader is ever in a position where they feel desperate enough to act on them blindly.
Yeah.
The responsible attitude for the scientific community is to study the mechanisms deeply, promise very little to the public, and stay rigorously honest about how much of the Earth's climate we simply do not fully understand.
Yeah. Because geoengineering is not a rescue mission. It is not a fantasy to make us feel better about driving gas guzzlers. It is a set of serious, sobering options that just reflect how daunting the climate challenge has become.
Well said.
The most important thing for you to carry away from this deep dive is a sense of proportion. The cheap, fast option is the frightening one that only hides the problem. The safe option is slow, costly, and extremely limited in scale.
Exactly.
And neither of them removes the need to cut emissions at the source. There is no substitute for tackling the root of the problem. We cannot reach for a planetary quick fix.
It's a vital reality check on the limits of human technology.
It really is. Now, as we wrap up today's deep dive into the atmosphere, we want to leave you with a final thought to ponder on your own. We talked earlier about the idea of a global thermostat and the terrifying reality that we do not have a spare planet. Consider the mechanics of our current geopolitical world. In a landscape made up of nearly 200 sovereign nations, what happens if one single country, perhaps a country experiencing absolutely devastating existential climate impacts like unbearable lethal heat waves or total agricultural failure, decides they simply cannot wait for a slow-moving global consensus?
Oh, it is a scenario that security analysts consider highly plausible.
What if the desperate government decides to unilaterally walk up to that giant thermostat dial we talked about at the beginning? What if they just start spraying reflective sulfur particles into the stratosphere on their own, using their own modified military or aviation fleet simply to cool down their own airspace and save their own people?
It's a scary thought.
How does the rest of the world respond to a rogue climate engineer turning the dial for everyone else? Do neighboring countries shoot those planes down to protect their rain clouds?
It is a question of international security that requires serious, sober thought long before anyone actually reaches for that dial.
Something to chew on as you look up at the sky today. Thank you so much for joining us on this deep dive. We'll catch you next time as we continue exploring the mechanisms and ideas that shape our world. Until then, keep asking questions.